Jai Hind everyone. This is Nitin Kumar Sharma from Department of Applied Sciences, Mathematics, Akgec Engineering College, and today's topic of the lecture is curve fitting, and especially we will discuss here method of least square. This topic belongs to the syllabus of Mathematics 4th, that is Engineering Mathematics 4th, BAS 303 for the second year students of the BTech. Alright, so the content of this topic is, this lecture is curve fitting, concept and the procedure in brief, writing the normal equations, fitting a straight line, fitting of a second degree parabola, fitting of exponential curves, and some other important curve we will discuss at the last. So first of all, the definition of the curve fitting. The curve fitting is a technique that involves finding a mathematical function that best fits to a set of data points. So basically we are given with some data in this style like x, y, and the data is given here like 2, 0, 1, 5 and 7, 0, 1, 9 like this, and then we have to determine some mathematical function related to this data. Okay, so the goal of this method is to find the best fit parameters that accurately represent the relationship between variables in a given curve. Then processes define an objective function, minimize it using specific algorithms and evaluate the results. Then purpose of it, the purpose is to understand the relationship between different factors within a data set. Then here are some methods for curve fitting. The graphical method which we use in the previous classes, and the method of group averages like time series, and method of movements we use in the statistical distributions, and method of least square. This is the method we are going to discuss today. Okay, so what is the method of least squares? The least square method is beneficial method of curve fitting, but it has some limitations. What are the limitations? For example, if it assumes that the errors in the independent variables are negligible or 0. So let us take the illustration for this, that what is the method. So as we are given with the data like x, y here, suppose there are some values here. Okay, then these values will create some coordinates like this will be x1, y1 and so on, and then we plot here these points, and this will create a scatter diagram. Suppose the scatter diagram is like this point, this point, this point, so these are the point plotted here due to the given data set, and then we try to fit a curve which passes almost from all points or near to the all points. Okay, suppose this is the curve, and the concept here is to minimize this error of distance, minimize this error like this. This is the concept. We try to fit the curve as that the curve passes through maximum points, or the distance of the curve from the points should be minimum. Okay, so this is the concept, and that's why we call this method as method of least square, because these errors can be negative and positive. So we will take the square and then take the minima of that. Then writing the normal equations for the given curves. Then first of all, let us take the curve first. For example, we are going to fit a straight line. So if you want to fit a straight line, then how we can write the normal equation? We are taking this procedure just in applied case, because we are not going so deep in the procedure, not so deep in the method. So if you want to fit a straight line, so straight line is basically y is equal to a plus bx. So this is the equation of the straight line, and we are going to fit it. And then first of all we will need normal equations. So the normal equations, therefore normal equations are, just take the summation of y and then plus b sigma x. Where is the variable? Then there you have to put the sigma. That means take the summation from the table. And then if a, this kind of constant is free, then we write here n a, where n is number of entries or data set. Given us. Okay. So in this way we can write the first equation. So how much the equations are required, how many number of equations are required? Then if we have two constant in the equation of the given curve, then we will need two equations. Then to write the second equation, we take the coefficient, variable coefficient of the second term, as the first equation is given in reference of the first term, and first term is constant. That's why we have taken it directly from the given equation. Originally we will take the sigma on the variable parts only. Okay, so we take the curve as 1 and this equation as equation number 2, and then here we write y and then multiply with this x. So the next equation is xy, and if we multiply this a by x, then a is outside, and then sigma x plus b sigma x square. Equation number 3 is the next equation. Okay, in the normal case, normal equation. And then for the curve of the second degree parabola type, so in the case of second degree parabola, we extend for second degree parabola. Second degree parabola can be defined as y is equal to a plus bx plus c x square. This is the standard equation of the second degree parabola. So in this case we write here the normal equation. Normal equations are, first equation in reference of the first term is sigma y is equal to n a plus b sigma x plus c sigma x square. And you can observe that we have three constants a, b, c in the standard equation. So we will need three equations. So therefore the second equation is with reference of the b, and therefore we have to multiply here x, and then here it will be a sigma x plus b sigma x square plus c sigma x cube. Okay, and then the third equation should be with reference of the third term, that is x square y is equal to a x square, that is b, next is b sigma x cube plus c sigma x raised to power 4. So these are the standard equations for the linear equation and the second degree parabola. Okay, and that was the straight line also. First equation, and these are the second, third and fourth for the problem. So this was the way to writing the normal equation. Okay, so let us take an example of fitting straight line. So if you want to fit the straight line, then the question is to fit a straight line to the following data by method of least square. Okay, so this is the data. So first of all, we will write the data in a table, and then we will write the standard equation of the curve, and that curve is here straight line. So this is the straight line we have to fit here. Okay, and then first of all we have to write the normal equations, so that we will understand that what are the number of column or the summations required from the table. That's why we will write the normal equation first, normal equation of the corresponding curve. Then as usual, I have already discussed that first equation is from directly from the given equation, and that is sigma y equal to, here notation m is taken for the number of data set, that is 1, 2, 3, 4, 5. Here m is equal to 5. So this value m is 5 here. This is here 5. Okay. So the first equation is sigma y m a plus b sigma x. Second is sigma x y equal to a sigma x plus b sigma x square. Okay. Then the table. From table, from the equations we can observe that we will need sigma y, sigma x, sigma xy, sigma x and sigma x square. So we can see that we will need 4 individual summations: sigma y, sigma x, sigma xy and sigma x square. After writing the summations in the table, we will put these summation in these places. Okay. Then you can see x and y are given in the table. These are the summations. Then put these values here in the equation, and these two will be the equation of linear non-homogeneous equation in 2 unknowns a, b, in 2 unknown quantities. Okay. So after solving these with the calculator, we get the values of a and b as 0.72 and b is 1.33. So these are the required coefficient and the constant values in the standard equation we have, and put these in place of a, b. In the standard equation we put these values here, and the standard equation is converted into the required curve. The answer is the y is equal to 0.72 plus 1.33 x. This is the required equation of the straight line. Okay. Now fitting a second degree parabola. So to fit a second degree parabola, we have the given data set x and y. We have 3 values here. That's why the value of the m, notation m here, we have discussed in the method is as it has n, and here it is m, and m is 3, 1, 2, 3. Okay. So the equation of the second degree parabola is given by this equation: y is equal to a plus b x plus c x square, and the normal equations are sigma y equal to m a with reference of this term, first term, and sigma y equal to m a plus b sigma x plus c sigma x square. Then the second is sigma x y is equal to a sigma x plus b sigma x square plus c sigma x cube, and third equation is sigma x square y equal to a sigma x square plus b sigma x cube plus c sigma x raised to power 4. So these equation number 1, 2, equation number 2, 3, 4 are the normal equation with reference of the first, second and third term. Okay. Now the value of m is 3 here, and we have to write the table to determine the values of these summations, like sigma y, sigma x, sigma x square, sigma xy, sigma x cube, sigma x raised to power 4 and sigma x square y. These are the individual columns we have to create in the table. So here you can see x, y, x square, x cube, x raised to power 4, x y, x square y, and these are the summation in the bottom of the table, and then these summations are substituted in the equation number 2, 3, 4. We get these kind of linear non-homogeneous algebraic equations in 3 unknowns A, B, C. Okay, and then solve these equations by calculator, and we get the values of A, B, C as 1, 2, 3, and then put these values in equation number 1. You will get y is equal to 1 plus 2x plus 3x square, which is the required equation of the second degree parabola. So this will be the answer for the given data set. Okay, so next is the fitting of the exponential curve. So this is a very important question for the point of view of the examination. The given data set is x, y. So these are the data tables we are given with, and this table can be changed, but you have to stick with the curves, especially because data can be anything. So you have to go with the procedure only. So if here we are firstly considering this kind of curve, there are many type of curve we will discuss in the next slide, upcoming slides. So y is equal to a e raised to power bx is the first exponential curve we are going to discuss. So basically, if you know about the fitting of straight line, so in the base of all the curves we will use the straight line only. Okay, so we have to convert all the exponential curve into the in a form of the straight line, and then using the concept of the straight line we can solve the problem. Okay, so here y is equal to a b y equal to a e raised to power bx is the given curve which we have to fit. So take log on both sides. Okay, we can take log on base 10 or base e also. Okay, so here we are considering log on base e. So if you are taking log on both sides, then you can see this will be the next line, and then consider these as new variable in capital form. So this log y will become capital Y, and log small a is capital A, and b log e is considered here as this constant. Okay, so here we have taken log on base 10. It should be noted here for the convenience that it is log on base 10. So here we can write base 10. Okay, then x is considered to be capital X just for the convenience of the capital letters. Then m is equal to 5 because number of data set is 5, number of coordinates are here is given here is 5. So create the table. Before creating the table we will write the normal equations, and the normal equations with respect to this, say that this is equation number 1, this is equation number 2, and let us write it equation number 3 and 4 to create the continuity. Then our target is to determine the equation number 1 with the help of equation number 2, and equation number 2 can be determined by the solution of the equation number 3 and 4. So to solve the equation number 3 and 4 we will require these summations. Now create the table, and to create the table we will take the data as small x and small y, and then we have converted the small x small y into capital X and capital Y. Then what is the value of the capital X? Capital X was directly small x, therefore there is no change in the value of capital X. So it is like this, and then capital Y was log y, then take the log y log of the y values of y, and then this table column will be appear, and then multiply these two column, we will get the product column xy, and then take the square of the capital X, we will get the last column. All right, now put the values of these summations in equation number 3 and 4 at the respective places, and then we will get these two equations. Okay, and these two equations are the non-homogeneous linear algebraic equation in two unknowns, and you can solve it using calculators, and then after solving these equations we will get the value of capital A and capital B like this. But these capital A and capital B are the not required value. We are required small a and small b for the equation number 1. We are working this procedure, working on this procedure for the equation number 1. That's why we have to take the anti-log of the values, because we have taken log here to determine the values of these constants. We will take a is equal to 10 raised to power value of a. This will be the anti-log. And for the b, and b is the constant, so there is no need of it. So take the anti-log for a only, okay, and then the anti-log is this value, so you get small a. And in case of b, because it is constant, so b can be written as capital B upon log e to the base 10, and then these are the values. After calculating the values, we get this value of the small b as 0.50001. Okay, now substitute the values of small a and small b in equation number 1, and after substituting these values, we get the required exponential curve. Okay, so this is the answer. So these are the reference books. Thank you.